So welcome back, and we are carrying on with our study of finance. So we're going to just take a few moments just to remind ourselves what we should know from our previous years, from grade 8, 9, 10, and 11. So we've got these four variables. P is what's called the principal amount, the starting amount. Then we've got A, which is the final amount, the accumulated amount. We've got I, which is the interest rate per period, and we'll talk more about that just now. And then we've got N, which is the number of periods. All right, and we've got four different formulae here. We've got two where things gain value. All right, when something gains value, I'm going to write that in green. Okay, and when something gains value, then obviously our final amount, our accumulated amount, is bigger than the original amount. Right, so we've got a formula for what we call compound increase or compound interest. Sorry, this one is not compound at all. This one is called simple interest. And then we've got compound interest or compound increase. Right, now inflation is always calculated with the compound interest formula. And it is always compounded annually. So inflation is always compounded, and it is always compounded annually, every year. Right, then we've got two formulas which involve what we call depreciation. And this is when something loses value. Right, and I'm going to write all of these in red, loses value. We've got this one, which is kind of like a simple simple interest decrease. And this is called straight line depreciation. And we need to know that term because questions will refer to it. Straight line depreciation. When something depreciates, it loses value. Right, and then we've got this one, which is sort of like a compound decrease, and its name is reducing balance depreciation. Very cold here, and my hand's cold and I'm shaking, and my handwriting is even worse than usual. I'm sorry. Okay, right, now in maths, when we have all the variables in a formula apart from one, we can solve for it. So we're going to do four different examples here. We're going to ask you to pause the video and we're going to ask you to try these examples. The first thing is to establish which formula must we use, all right, and then put in what we know and see if we can solve the equation that results. Okay, we're going to ask you to pause and try, and then we'll go over them shortly. Just the next four questions. Okay, so this first one, I invest, all right, at 12% per annum. How much do I have at the end of 5 years? Well, the formula we're going to use is our increasing formula, an appreciation formula, and it's compound, so it's 1 plus I to the power of n. So our answer is just going to be my 100 Rand, 1 plus our interest rate is 0.12, and we are investing it for 5 years, and so there's going to be our answer there. Now, just before we sort of do anything further here, I just want you to understand that we've actually got a multiplier in here of 1.12, and we're raising that to the power of 5. Right, when we multiply 100 by 1.12, we are growing it by 12%. Let's just show you 100 times 1.12. Right, that's how much we would have after 1 year. Then we need to multiply that by 1.12. and that's how much we'd have after 2 years. Times it by 1,12 again, that's how much we'd have after 3 years. Times it by 1,12 again, that's how much we'd have after 4 years, and times by 1,12 one last time. 176 Rand and 23 cents. 176 and 23. Right, we hope you understand where this formula comes from. It's just repeated application of a multiplier. We just keep growing our amount by 12%. Obviously, we wouldn't expect you to do it like that. We'd expect you just to type it straight into your calculator as 100 times by 1,12 to the power of 5. And there's the answer that we got. Okay, right. Let's look at the next one. 3 years ago, I invested some money at 10% per annum simple interest. So the formula we're going to use is this one. But this time, we're not asking for the A value. We're actually asking how much did I start off with? How much did I invest? We know that we end up with 520 Rand. We want to work out the P value. This is going to be 1 plus, the interest rate is 0,1 times 3. So in fact, we're going to take this in the brackets here comes to 1,3. So we get 520 is P times 1,3. We're going to divide both sides by 1,3 and we get P equals 400. Okay, 400 Rand. Okay, let's look at this next one. An item depreciates according to the straight line method. All right, now that's going to tell us which formula to use. According to the straight line method. Okay, we're going to use this formula. A equals P 1 minus I to the N. Okay, and we know that it depreciates from 500 to 200. It starts off at 500 and it ends up at 200. Remember, depreciation, our A value is less than our P value. We don't know the annual rate of depreciation. That's what we're trying to find. And we know that this is over 4 years. How many variables are left here? Only one. Elilodwa, just one. All right, what should we do to both sides to solve this? Well, let's divide both sides by 500. 200 divided by 500 is just 2 divided by 5. It's just 0,4. And this is equal to 1 minus I to the power of 4. What power should I raise both sides to get rid of this power of 4? That's right, 1/4. So in fact, 1 minus I is 0,4 to the quarter. Let's add I to both sides and let's subtract 0,4 to the quarter to both sides. We end up with I equals 1 minus 0,4 to the quarter. Okay, let's work that out on our calculator. 1 minus 0.4 to the power quarter. And we get 20,48%. Okay, we're running out of space a bit here, but let's write it over here. I equals 20,48%. Okay, and I'm sorry I've messed this up completely. I've just realized I've used the wrong formula. I wrote down the wrong formula. The straight line method. Sorry, guys. Okay, I'm too early in the morning. All right. Straight line method is not that formula. The straight line method is this formula. Okay, so 500 to 200. 200 is our A value, 500 is our P value. 1 minus 0, we don't know I, we're working out I, times by N, N is 4. Okay, all right. We're going to divide exactly as we did last time. We're going to get 0,4 equals 1 minus 4i. We're going to add 4i to both sides, and we're going to subtract 0,4 from both sides. So we actually get 4i equals 1 minus 0,4, it's 0,6. Divide both sides by 4 and we get I equals 15% per annum. Okay, apologies for that. Right, now the next one says, if my car depreciates at 15% per annum by the reducing balance method, how long will it take before it's 1/5 of its value? So this time we're using this formula, A equals P, 1 minus I to the power of N, okay? And it's going to depreciate to 1/5 of its value, right? So we could either use a number here. For example, we could use 100 Rand as our P value and 20 Rand as our A value, or we could say 1/5 of P is our A value. We know that this happens, the interest rate is 15%, 0,15 to the power of N. Okay, now when we divide both sides by P, we just get 1/5 here, right? And if we'd used numbers, we would also get 1/5 here. So now we've got 1/5 equals 0,85 to the power of N. And this is where we're going to use our log function, okay? N will be log, okay, base 0,85 of a fifth. Okay, let's work that out. Log 0,85 and 1/5. And we get about 9,9. It says to the nearest years, so 10 years. Okay. Right. Now we're going to talk about different compounding periods. Okay. And remember that the I value here refers to the interest rate per period. Okay. So for example, if I've got 12% per annum and it's compounded monthly, then I get 1% per month. If it's compounded quarterly, I take my 12% and I divide by 4 and I get 3% per quarter. Right. The more often the interest is calculated, the greater the final amount. All right, let's look at some examples. So I invest 5,000 Rand for 5 years at 10% per annum. All right, so and in each case here we're using this formula, A equals P, 1 plus I to the power of N. This is our kind of bread and butter compound interest formula. Okay, so if interest is compounded annually, I get 5,000 Rand is my P value. 1 plus, it's 10%, so it's 0,1, and I'm just going to compound it annually, and we're going to get that answer. All right, now let's work that out. So it's 5,000 times 1,1 to the power of 5, and we get 8,052.55 cents. Now we're going to work out if we calculated the interest twice per year. All right. So what will happen now is we've still got 5,000 here, but instead of our interest rate being 10%, it's only going to be 5%. But we're going to calculate it twice per year, which means that in 5 years we'll calculate it 10 times. Let's work that out. All right, so now we've got 5,000 times 1,05 to the power of 10. And we get 8,144 and 47 cents. 8,144 and 47 cents. Now that's slightly more than before. And the reason it's slightly more than before is because after half a year, we already get some interest. And in the next half year, that interest gets a bit of interest. So we earn interest on our interest. And that's why the more often we compound, the better it gets, okay? We want you to pause the video and try now quarterly, monthly, weekly, and daily. All right, and see how that looks. Okay, so quarterly will just be 5,000. Now we're going to get 1,025. That is 10% divided by 4. But the interest is going to be calculated 4 times a year for 5 years, a total of 20 times. We'll work these out just now. This one is going to be 5,000. Now we're going to get our interest rate is going to be 1 plus, our interest rate is 10%, but we're going to divide it by 12. And in 5 years, there will be 60 months. All right, this one, 5,000. 1 plus 0,1 divided by 52. 52 weeks in a year. And now this is going to be 5 years times by 52. Right, that's how many times the interest will get calculated. And then daily would be 5,000, 1 plus 0,1 divided by 365, and this will be 5 years times 365. All right, let's work out each of those numbers and just see what they come to. And we'll see that it keeps improving slightly each time. All right, so 5,000 times 1,025 to the power of 20 1,025 to the power of 20, 8193 and 8 cents. Okay, let's look at this one. It's 5,000 times 1 plus 0,1 over 12 to the power of 60. And we get 8,226 and 54 cents. Okay, let's look at this next one. We're going to get 5,000, 1 plus 0,1 over 52 to the power of 5 times by 52. And we get 8,239 and 65 cents. And then the last one, if we calculate it daily, we get 5,000, 1 plus 0,1 over 365 to the power of 5 times 365. And we get 8,243 and 4 cents. 8,243 and 4 cents. Okay, right, we're going to stop there. We're going to ask you to try, before the next lesson, we're going to ask you to just look at the questions on page 6 and try those 2 questions, and we look forward to going over them with you next time. Have a great day, everyone.